Hi everyone, this is Tim here at Makers Machining again. Just wanted to get another episode going here and talk about the metals that are used in machining. And we're talking about metals for now, but there's a lot of other materials out there too, plastics and that type of thing. We'll cover that probably in another episode here, but I wanted to talk to you about the metals used in machining. But before I get into that, I wanted to mention here that we've had a bunch of papers that I've held up for you to look at, and now I've got an email address. If you would like to send an email to me, I can send you a copy of our print for our drilled block or some of these other documents that I've had. And if you send me an email, I'll try to keep you on a regular posting on what we have for the various subject matter. So anyhow, the email address you can send to is ask me to send a specific document or whatever you need, or I'll send you a few of them, what we've covered. But our email address is makers.machining@gmail.com. Send me a note and I'll be able to keep you posted on some of the different things that we've talked about. I've had our print for our drill block here, and this is certainly not the way to send it to you or expect you to work with it. So if you would send me an email and ask me for the print, I'll be glad to send that out to you. Anyhow, talking about the print, as we do machining, our print will have, or our sketch will have some notation on what kind of material to use. There's a lot of different metals that are used in machining, but I think the first thing you look at is when you make a part, you're going to make it out, let's say you make it out of some steel. You're going to need to get the material. So where do you go and get a piece of steel that you want to use to make your part? Ours is a 1-inch square 1018 cold rolled steel bar that's 6 inches long. So we'll start and use that as an example. So where do you get the material to make a part, or any other little idea that you have that you want to work on, or an invention or something? You got to get the right material. So it's like telling somebody, well, I want to buy a car. Well, what kind of car do you want? What do you want on it? This and that. So it's up to you to find out what kind of material you need for your project, and you can talk to a steel salesman, and they might give you some options to consider. So let's say we're going to get a piece of material for our drilled block. So I mentioned a couple things that you could do here as far as getting material. You could if you're in a shop class, you can go to the steel rack and find out what kind of material they've got there. If you work at a factory somewhere that has a stock room with some steel material in it, you could go there. If you don't have access to anything like that, you could go to a local scrap yard, because a lot of times scrap yards will have material that they've purchased out and sell it to consumers like us. Or you can go to a steel service center that sells metals. So you say, okay, I need a piece of steel. Okay, like I said, that's a pretty general term. Steel is something that's pretty tough. A magnet will stick to it. It'll get rusty. It weighs a lot. Those are some of the features of steel. But if you're going to be doing some welding to it, you need to have the right makeup of metal that will allow you to weld. You can pretty much weld anything out there, but there's certain techniques to doing it. If you're working with some alloy material, you can't just weld it together, because if you're using alloy material and you get a MIG welder or a stick welder and you weld it together, good chance it's going to crack and break on you. And that's a safety issue in a lot of cases. So what kind of material do you get? So you could call up a steel service center, let's say. That's a place that will sell all kinds of different steels. And you can tell the salesman, I want a piece of steel. Is it hot rolled? Is it cold rolled? The guy's going to ask you, what do you want? And if you're not sure, then you ask him. Tell him, I'm making some block. It's a drilled block. It's 1-inch square. It's got to be accurate. So he'll probably tell you to use cold rolled steel, 1018 cold rolled steel. That's the basic metal. And he can give you some advice as to what you want to use. There's many different grades of cold rolled steel. Cold rolled steel just tells about what the finish condition is of the metal, the outside dimensions. He could say, okay, I've got some 1-inch square hot rolled steel. I've got some 1-inch square cold rolled steel. Hot rolled steel, pretty much, there's not as many alloys to pick from, and that's usually good. Hot rolled steel is usually good for if you're going to fabricate some kind of a rack or do some welding and that type of thing. You get it in hot finish condition. That's usually called A36 material. It's good for welding. First job I ever did for myself was make a steel rack, or a rack to put materials on. A lot of steel went on there, and I could use it for shelving for other storage too. But that was one of the first things I did. So I used angle iron, which is a hot rolled steel, welded it together. But in our case, we have a block that we're making. We want a nice finish on it for our dimensions. It's got to be accurate. We don't want to buy a big piece and machine it down to 1-inch square, because that takes a lot of time to do that extra machining. So you can get cold rolled steel 1-inch square. But then the question comes up, well, what alloy do you want it? Okay, the alloy dictates, the application, how it's going to work, what kind of strength it has, tensile and yield strengths, that type of thing. So the steel service center guy, for example, he's going to say, well, what alloy do you want? And you can ask him. I said, well, I'm making a bar that's got to support some weight. What do you recommend? So you've got 1018 steel, which is just run-of-the-mill, nice, clean metal. You can get 1045, that's got more carbon in it. You can still weld 1045, or you can go up to a grade of like 4140 material. That's a high strength alloy. So if you've got something that's really taking some heavy load, maybe a bearing housing that you have to have a bearing in there and there's some weight on it, 4140 is a good material to use for that. But the alloy is an effect on welding. So if you're going to weld something, you have to have special welding rod if you're going to weld alloys or higher yield and tensile strength, higher carbon content material. So you can ask your steel service center guy, what he's got and what he recommends. He's probably going to give you some suggestions, but he's not going to tell you what to use, because that's ultimately up to you. You have to know what you're making and what some of the ramifications are if you use one grade versus the other. You have to do a little homework. Most steel service centers, the bigger ones, have handbooks that you can get, and I should have had one here to hold up in front of you. But you can look in this book, and it'll tell you all kinds of stuff. It'll tell you the sizes that are available commercially, the different alloys that are available, and usually in the back of the book there's an index back there that tells the mechanical and chemistry composition makeup of different grades of material. And of certain interest would be the mechanical properties that tells you what the tensile and yield strength of a given alloy material is. And I say alloy, 1018 is an alloy. It's just 1018 is what the material composition is versus 4140 or 8620. There's a lot of different kinds. So you're going to have to do a little homework on that. If you get a steel service center catalog, you can get that information online if you want, just to be a little cautious what you use. I went to the scrapyard when I first was getting set up to do things. I went to the scrapyard and I bought a piece of round bar. I think it was a 2.5-inch diameter bar or something like that. It was a couple feet long, and I thought, that's great. I can have a nice chunk of material and do lathe work. If I have a job where I've got to make a shaft or something, I can put that up and cut it to length is what I need, and I've got a nice piece of material. Well, I learned the hard way. I got that nice looking shaft in and had a project I wanted to do and cut some material up there and put it up in the saw. Came down, and that saw wouldn't even scratch that thing. It was hard as a rock. I couldn't cut it. And I had a good saw. It just couldn't cut it. It was a heat treated bar. I couldn't do anything with it. So I went back to my guy that I bought it from. He gave me my money back, and I bought another piece of material, and I checked it before I picked it out and took it, because the way to check to see if a piece of material is hard is to take a file and just tip the file up on an angle and get the corner of the file and run it along and see if it cuts a little groove in the piece of material. If it does, it's going to be machinable. If it doesn't, it'll zing right across the top of that piece of material, won't hardly scratch it, you know you've got something that's heat treated. So I learned, you know, I was going to the scrapyard. They couldn't tell me what the material was. I didn't know what the material was. A lot of times you'll have markings on the material that people mark the alloy that's on there, because if you buy a bar of material and you use a piece here and a piece there off that bar, you better make sure you mark what the material is on the bar so you know what it is, because you may have some bars of steel that are cold finished that look alike, but they're different alloys. So be very careful with that. If you're not welding, if you'll never weld on the piece, you can probably pretty much use any piece of material that you have. But if you start to do something with welding on it, you got to use the right material. Different materials that are out there that are, or metals that are machined. I've got a list here, and like I said at the beginning here, if you send me an email at makers.machining@gmail.com, I will send you this list so you can look at it. There's so many different varieties out there. We got carbon steel material, we got alloy steel material, aluminums. There's different grades of aluminum, brass, bronze. You don't want to confuse bronze with brass. Bronze is a material that's used for bushings, or there's different alloys of bronze that are good for wear surfaces on a machine maybe that's going back and forth, whereas brass is kind of the same color, yellow, but it won't hold up for anything. It's got no hardness, no wear properties. It's good, maybe good for electrical conductivity, or making a hose or a fitting or a valve or something that doesn't rust. That's probably what that's for. So a lot of plumbing fixtures are made out of brass or copper. Copper's another material that you work with. It's got its own applications that are good for. Electrical conductivity is really the main one for that. There's also stainless steel. Different grades of stainless steel. 304 stainless and bar stock is a common material that's used out there. 316 grade of stainless steel is used in food applications. So if you're making something for where there's food involved, processing food, you have to use 316 stainless. Both the 300 series stainlesses that I just talked about, 304 and 316, a magnet will not stick to them. So that'll tell you a hint right there. If you got a bar, it might look like a piece of cold rolled steel, and if you're not sure if it's stainless or not, take a magnet and put it on there. Magnet will not stick to stainless steel in the 300 series. In the 400 series it will. There's also a 17-4 stainless, and that's a precipitation hardening material. It gets harder as it's used. Then we got the real specialized steel, tool steels, A2, D2, O1, M2, S7, H13, all are used in certain applications. H13 is for working with hot stamping, for example. S7 is where it will take an impact blow, shock resisting. M2 is what drill bits are made out of, super hard. O1 is an older grade of tool steel that you heat it up, throw it in a bucket of oil, and it comes out hard. It doesn't stay very stable in size. Could crack from the drastic quench. A2 and D2 are tool steels that are hardened in a vacuum furnace, as well as these other ones too, M2 and S7 and H13. They're all done in an atmosphere controlled furnace in most cases. You don't have to use that, but that's the best results that you'll get out of heat treating tool steel. But anyhow, steel is a big mystery for what the best application is, and I'll send you this chart. Send me an email. We'll get you on the right track here with some of the things that are used. If you have any questions, give me a holler with the email. I'll try to give you an answer on that. But this is kind of a real easy entry level to metallurgy. So we'll be doing another view on plastics, that type of thing. You could call that plasticurgy, I guess. But anyhow, metallurgy is a big deal. Very important in today's working with metals. There's so many alloys, so many mixtures they've made of steel that apply for certain things. It's really interesting. So there's a field of work right there. Metallurgist, chemist, that type of thing. It's interesting work. So, and everything today has to have traceability. So that's the way you have to go. I see behind me the clock. It says it's 5:30, so it's time to call it a day. We'll talk to you soon. Make sure you like the video, and we'll send you more information. Send me an email. Take care. Bye-bye.